Hello and welcome to physical science class. As you know, I am Mrs. Newman and I am not here today because I am in school. Today was Take Your Parent to School Day, so I am in 8th grade going to all of my daughter's classes. So I have a recording instead. Hopefully you're watching this during your regularly scheduled time. And today's topic is naming ionic compounds. And today, of course, is Monday, September 23rd. So just to think about for a moment, what are chemical bonds? If you need additional time, you can go ahead and pause it. So chemical bonds are, an attachment between two different elements. And there's two ways or three ways that you can hold them together. The first way is a covalent bond where the electrons are shared equally. And the second way is an ionic bond where, like in the little picture there, it says, please just take him. So they give one electron to a second element. So you have a metal with a non-metal. The third type of chemical bond is metallic, and that's when you have all metals connected together. So today, our standards of excellence, we're going to work on SPS 2C, which is naming chemical formulas. So we're switching between their chemical name and their chemical formula. So before we do that, though, I thought we should probably review a little bit. So go ahead and pause this and read and get your guess. And then when you've got your guess, then hit play again. So pause it. And the answer is, what happens to the electron in an ionic bond? Are electrons shared? No, because that's a covalent bond. Are electrons removed? No. Then they can't go anywhere, and then there's nothing to cause them to stick together. And what electrons? Of course, it can't be the tortoise there. So it has to be our OK symbol that electrons are transferred. When you transfer that electron, then you get a positive ion, which is a cation, a negative ion, which is an anion, and they stick together through electrostatic forces. Right. All right, I've lost my mouse. Interesting. Where is it? Oh, it's way over there. Okay, sorry, drawing on the cat, trying to find the button. All right, here's the next one. And again, pause this, figure out your answer. And let's see what the answer is. What type of elements have ionic bonds? Oh, if you have all nonmetals together, that is going to be a covalent bond, and you make molecules. Noble gases don't bond with anything. If you have metals bonding to metals, you get a metallic bond. And so we're left with the turtle. The turtle wins. So metal bonded to nonmetal, that is an ionic compound. All right, so remember, ionic bonds occur between metal and nonmetal. Electrons are transferred. Aha, here's our cation and our anion. Ions are positive because cats are the most positive animal there is. And anions are negative. I don't know a way to remember that. I just remember the cat ones, and then I go from there. So remember, a metal is all of this blue stuff on the periodic table. It will include the lanthanides and actinides. So those are the metals, and they bond with a non-metal, but not the noble gases. I was going to circle those noble gases. They don't actually make any bonds. All right, so your essential question today, how are names and formulas written for ionic compounds? So in your Canvas lesson today, you are going to figure out how to predict formulas for stable ionic compounds, and how to write formulas for stable ionic compounds, and how to name them with the IUPAC. That's the International something, something, something. They're the body that decides how things are named in chemistry. It'll tell you in the lesson, because I watched the lesson, it tells you what it stands for. Okay, so now is the time where you can go through and get yourself some knowledge, because knowledge is power. And you don't have to skip number 6 and 7, but those are about polyatomic ions, and in the standards, it specifically says that they are not going to test you on those. But if you like to go above and beyond, if you are in honors, you should probably go through and just do 6 and 7 as well. So pause this and then come back. I'm not done yet. All right, so pause this, come back when you're finished, and watch the rest of the video. All right, I am back. You should be back, and hopefully you have completed the ionic naming ionic compounds lesson, and you've emailed me any questions that you have. And here I want to just show you a couple of writing formulas just in case it was hard. So basically, there are 3 steps to writing a formula. So first we have to figure out, where are these elements on the periodic table? What are their symbols? So let me just see here. Nope, that's backwards. Figure out which one. Okay, so this is the good one. So the first thing we have to do, this is from the formula for beryllium and fluorine. So first thing I have to do is find beryllium. There it is. Beryllium is, there it is. It's number 4 on your periodic table. It is in group 2. Because it is in group 2, how many valence electrons does it have? 2. And since it has 2 valence electrons, it will give those both away, and we will end up with a +2 charge. Fluorine is over here in the halogen group, right? Group 17. And it has 7 valence electrons. It prefers to gain 1 electron. So it will always form a -1 charge. It gained an electron. Oops, and there's my -1 charge. And then we basically crisscross these numbers. So the beryllium's charge becomes fluorine's subscript. And the subscript tells us that there are 2 fluorine atoms in this compound. So that's what the subscripts are for. Fluorine has a 1 charge, so our subscript on the other element is a 1. And because of that, then we can write the formula as BeF2. And for the ending, I can't see my other screen. Oh my gosh, it's crazy. I'm just going to tilt this down a little bit. There is the formula. And then our ending, sorry. Our ending there, we always add IDE onto the end of the non-metal. All right, so I bet you're having questions. Let me show you what this kind of looks like in real life. If we could zoom down into the molecular level. So beryllium had 2 valence electrons, 1, 2. Fluorine has 7. And so beryllium gives 1 of its valence electrons to 1 fluorine atom, and beryllium gives another 1 of its valence electrons to a 2nd fluorine atom. That way, beryllium gets a +2 charge, and each fluorine gets a -1 charge. If you add those all together, +2, -1, -1, we end up with 0 charge. And that means your molecule is stable and happy. Stable and happy when they all add up to nothing. They want to be neutral. Neutrally happy. All right, and again, if you have questions, one, I can answer them on our block day, or two, you can just email them to me, and I will get back to you as soon as I can. All right, here's another example. That's very interesting. Let me go and figure out what elements these are. I'll be right back. So we are going to do our second example with calcium and phosphorus. So the first thing I did is I went and found calcium on my periodic table. And what charge does it have? What charge is it going to get? How many valence electrons does it have? And again, pause if you need more time. But calcium is going to be a +2 because it has 2 valence electrons, and it's going to get rid of both of those valence electrons. Phosphorus, we want to find phosphorus on the periodic table. And phosphorus is in group 15, means it has 5 valence electrons. So how many more does it need to get to 8? 6, 7, 8. It needs 3 more electrons to get to 8. So its charge is going to be -3. All right, so now we have the formulas and we have the charges. Now we can cross them. Let me change colors. So I'm going to take calcium's and put it down under phosphorus. And I'm going to take phosphorus's charge, and these are always positive because subscripts tell you how many you have, and you can't have a negative number of atoms in a formula. So calcium ends up with 3. So we have Ca3, and phosphorus ends up with 2. So Ca3P2, and that is going to be our formula. So what are we going to call this thing? So think about it for a sec as to what you're going to name this element, and pause if you need more time. This is going to be calcium phosphide. You add the IDE on the end, and that will work. And there is our solution. And again, pause it if you want to look at this longer. I do have the explanation of how this works. So we've got 3 calciums. Oh, these are the big ones. They don't seem to be labeled. With the orange around them, those are calcium. I thought I had labeled these. And then 2 phosphoruses. I've lost my mouse again. There it is. And you can see that each calcium is giving up 2 electrons. In some cases, they might give them to a different phosphorus. In some cases, like this one over here, it gives them to the same phosphorus. All right, so if you have questions about calcium phosphide, please send them by email or just hold off and we'll answer them in class on block day. Oh, and there is with all of the charges. And if you add up all the charges, they will total up to 0. And that is when an ionic compound is stable, when the whole charge adds up to 0. All right, so your turn to try. So go ahead and pause this and take a moment to figure out the formula and the name of the compound between lithium and oxide. And when you're ready, just unpause it and I will show you the solution. So here we have lithium. Lithium is number 3 on your periodic table. It is in group number 1, so lithium has a +1 charge. Oxygen is over here in group 16. Can you see it? I can't tell. Oxygen's in group 16, so it has 6 valence electrons. It wants to have 8 to be stable, so that means it's going to need 2 more. When it has 2 extra electrons, it will have a -2 charge. And then the next step is to cross these. And so lithium will have a subscript of 2, and oxygen will have a subscript of 1. And I'm not going to write that because you don't need to. It's implied if there is no 1 that there is 1 of them. And then the name for this is going to be lithium oxide. And you can see how bad my writing with the mouse is. Lithium oxide. Oh, I was going to make a Q. O, X, I, D, E. I'm writing like I'm in kindergarten. Goodness gracious. All right, so if you have questions, again, email me or hold them, write them down. We'll talk about them in class on the block day. And that's it. Thank you for watching and have a wonderful Monday. I will see you in class.